Today is an exciting day. You're going to get the last of all your derivative rules. So there's only 2 more rules to get in your memory. So I'll show you. Because we're going to do all of our exponentials and logs, but that's only 2 because you already know. Let me remind you of things you already know. You already know this, and you already know this. Oops, lost my input. So if you already know those 2, the ones that are not base E are similar. So we also need to do the derivative of anything to the x, and then the derivative of log base anything of x. And they're similar. So e to a power, the derivative of e to the power is just e to the power right back. And so is this one. But this has an added, not plus, but an additional natural log of the base. So if you're wondering why, like how come, this one has it too. Surprise. It's just the base is e and the natural log of e is 1. So we don't write it because that's a waste of our time. And then it's very similar over here where, again, it's 1 over x, but it has this additional natural log of the base. Just like up here, you have a natural log of the base. And again, the natural log of e is still 1. So they're very similar because they're both logs. They just have different bases. The proofs for these are, they're kind of circular, like you end up making the same argument back and forth, but they're very similar to the inverse derivative proofs where you set it up as an inverse and then divide things over. So I'm not going to. Put these in your notes, put them in your memory, and then second to last thing for derivatives, last part of this video though. So you know how, theoretically, you know how to take this derivative, and theoretically, you now know how to take this derivative. So this is a power rule, no big deal. When you have a base of x and a power that's a number, this is an exponential when x is your exponent and your base is a number. But what about the case where you have a base that's a function of x and a power that's also a function of x? These are called, lovingly, hyperexponentials. I will bet you my paycheck that you have a hyperexponential derivative on your AP test, probably in the multiple choice section. But I would bet money on it. So hyperexponentials. Please know that they can be a lot more exciting than just x to the x. Like it's any function of x. So we could have sine x raised to the square root of x. They can be super fun. These are not a rule. Like I'm not going to teach you, here's the rule that it always equals. I'm going to teach you a process to take these derivatives. So I'm going to erase this one away, and I'm going to teach you this process using the most basic, just x to the x. All right. Base x is terrifying. I'm very scared. So I think instead, I'm going to rewrite this weird, strange function, not as base x, but as base e. Can I do that? Like, am I allowed to just make things base e because it makes me feel better? Sure, as long as I throw a natural log up here. So I haven't done anything, right? These are equal signs. I'm just rearranging. But throwing logs into your expressions allows you to do really fun things like log rules. And you have this really strange log rule that says exponents can fly down, they can birdie down. And so we can think of this as e to the x times natural log of x. And maybe you don't think that's any better, but it is, because now I'm doing this rule. I'm doing an exponential rule. And let me keep going up. I'm doing this rule. I'm taking the derivative of e to a power, and I can do that. So we haven't taken the derivative yet. All we did was rewrite the problem. So this is the derivative of e to the x log x is what we're doing instead. It's the same question. It's just a rewrite, but now it's in a form where I can differentiate it. All right, so let's talk about it. E to a power, the derivative of e to a power is the same thing right back, but this one has a chain rule in it because its power is a function as well. So I have to go in and take the derivative of the power. Okie dokie. Well, this power is a product rule. So inside that power, I'm going to do a product rule of first, derivative of the second, so 1 over, plus second, we just write it. Derivative of the first is just 1, and that's great. The end, kind of. So I know I've said you don't need to do a lot of cleaning. Here's the cleaning that you absolutely must do. This has to go back. Like, you have to clean up after yourselves. Like, you made this mess, you have to put it back how you found it. Remember, it started here. Or it didn't start here, but you turned it into that. It started here. So you always have to put that back. So just put it back the way you found it. And then while I'm rewriting, like, I have to. I can't leave that as x times 1 over x. I think I would get fired. That's it. That's how you take derivatives of hyperexponentials. Again, there are so many students, well, not so many, but there's always a student every year who makes flashcards, and they make a flashcard for this, and they say it equals this. And I mean, they're not wrong, but this is not a rule to memorize, because the second I change it up on you even a little bit, now this rule doesn't apply. Like, it's not a rule, it's a process. So let's do another one. I'm going to write another one. You're going to pause and you're going to try. What do you want to do? How about a trig? How about a trig and how about like a root, a radical? How about a cube root? All right, pause. Go make it base E, and then unpause, and I'll catch up with you. Okay, if I'm going to turn this function into something that's base E instead of base tangent, which, oh my gosh, I need, because I don't like base tangent. It's going to be E. I can't just E things because I feel like it. I have to put a natural log, and then I'm rewriting. The reason we do that is so that we have these fun power rules, these fun log rules, where we can birdie things down. I hope you know what I mean when I say birdie. Some of your kids give me a strange look, and I think maybe your Algebra 2 teacher never said birdie rule, and so I just sound like an idiot, but I can't see your faces, so I don't care if you think I'm an idiot right now. So we're going to birdie rule that down, and now I have e to a power. So if you got here, congratulate yourselves, and now pause again and see if you can take the derivative of that. Hi, I'm back. Let's see if you took the derivative. So now we're differentiating e to the cube root of x times natural log of tangent. You got some chain rules in here, kiddos. Let's see. All right, derivative of e to a power is the same thing right back. So all I have to do is write it. I'm really good at that. Now, I have a power to also differentiate. That's my chain rule. That's one of my chain rules. All right, that power is a product, so I'll do product rule. It says first, got it, derivative of the second. Okay, natural log rule is 1 over your input. My input is more than just an x, so I have a chain rule here. So natural log is 1 over times the derivative of what's inside is times a secant squared. Okay, so that was first, derivative of the second, plus second, I just have to write it, derivative of the first, remember this is x to the 1/3, so when I pull a power and subtract 1, it looks like this. These answers are always really messy, and that's okay. Just clean up after yourself. Here's what you have to clean up. You have to clean up this thing that you made, this e to the thing that you made. So it's always going to go back the way you found it, tangent to the cube root of x. And then anything else you want it, like, I don't see a point in writing these separate, so I will at least smush them into one fraction. I mean, not the whole thing. I'm not doing a common denominator. I'm not a lunatic, but I can at least write a numerator over a denominator instead of a bunch of times whatnot. And I'm going to clean up that exponent, that rational exponent. But if you hadn't, I wouldn't care. The end, I think. Yes, that looks good. All right. Hyperexponentials are probably one of the tougher concepts in derivative rules. There is one in your next homework turn-in. So if you want to go do that one straight away while it's fresh in your mind, that would be a good idea. Otherwise, we'll maybe do one or two in class when I see you next. Let me know if you need anything.